So hello guys, welcome back. Good evening, all of you. Today we will be, so as you know, that we will be starting the Platinum course, and we have a plan in our mind. We have already shared the plan with you, and the plan starts with mathematics as the first topic to master. Today's plan, today's goal, today's aim is to help you understand what lies in front of you in mathematics course and a brief intro to all the courses too, like a basic intro and what books to follow and how the entire course will work, what are the small aspects to it, and what I and we as a team want you to do as a team, as an unit, so that you perform the best in the examination, also build your foundations well. So I've made a presentation for you to help you understand visually and make the whole process of learning faster and understanding faster, so that we can, you don't to feel bored in the class. I know how it feels to get bored in the class. So first of all, as you know, our whole goal is to help you build your foundations, and accordingly, the byproduct is to ace your examination. But how are we planning to do that? So by our learning path, what's your learning path for you? So as you know, I will just repeat it once again. From February, your mathematics full course will start. It will end in May. In the starting of May or the middle of May, and then the probability, all these things will start. So at this point of time, I expect you to be really proficient and really comfortable in your own skin in the topics of high school mathematics. So before I proceed towards the next part of the presentation, and I know what's in line, ahead in the course, so I would like to know who have done more than at least 70 problems in the whole, who have done more than 70 problems in the high school mathematics uh, problems, 101 problems I've given. Can you raise your hand, please? More than 70 problems at least. Okay, that's great. Ronit, Shukanya, Chandre. That's great. Anyone else? So anyone did 100 plus problems? Did someone go to the reach the 100 level? All the problems? Okay, Chandra did that. Okay, no one. Okay, that's great. Anyways, that's good. So 70 plus 70% is good. That's really appreciable, the efforts you have put in. I understand also, I understand students who have not been able to do that, either they have joined late or they didn't get time. I understand you are busy. But thanks to those, Chandra, Shukanya, and Ronit, for devoting their time into learning and developing your basics. I really appreciate that. And if you continue doing this, you will be rewarded in Cheenta, as for performing the best of your abilities. So, okay, coming back to the course that we have, there's only one prerequisite, and that's high school mathematics, and they know that, and I hope others have done that too. I will come to that towards the end of the section, like last section, that what's the preparation and how have you done, what's the issues, how can you um, focus on those in the last 1 week before the course starts full course. So there are 5 modules, to be very precise. First, sequence and series, and differential calculus, integral calculus, linear algebra, and multivariate calculus. And the total approximate time of studying and learning together and exploring together is around 13 to 15 weeks. And you can see that when the topics will be done during which time point. The May part is divided into half, because we'll take at most 15 weeks, is around 2.5 months. Okay, so we can take at most, like 3.5 months. So we can take at most around 3.5 months to complete the course. And that's great. That's great. I think we have done this last year, and it was great. I hope this time it will be even better. The approximate time of studying each of these individual modules are, sequence series around 2 to 2.5 weeks, differential calculus around 2 to 2.5 weeks, then integral calculus 1 to 2 weeks, linear algebra for 5 weeks, multiverse calculus for 3 weeks. The detailed plan of each of those modules, we have been able to successfully implement that this year, like the last course, and hence, of course, we will be doing that in this course of yours. And yeah, so, and if you do the average, the sum, it's around 14 weeks. So if you do the minimum, that coming out to be 13. If you do the maximum, it coming out to be 15. You can calculate that. Okay, so, and how many classes per week? This is very interesting, and this has been fun for us and for the students. So number one important thing is that attending live classes is very important, and it's we have found it to be correlated with success in the examinations. But it's correlated, it's not causation, you know that. So we don't know whether it's a causation of that, but yeah, it's correlated. So it's your own choice whether you will do it or not. Of course, you will get the recordings and stuff. So there are 2 theory classes and 1 problem-solving class. And of course, in theory classes are like theory and problems, okay? Alternate theory and problems. But problem-solving class is totally dedicated to problem solving. The problem-solving classes are usually focused on. So we give the assignments in 2 formats. So one assignment, like the solving assignment, okay? So the solving assignments are of two, contains 2 types of problems. One is from the problems, theoretical problems, like problems which we think are important to build your foundations to make your core very strong, and the other aspect is to make your problem solving like of past year solutions of past years are really um, and you understand. So one way to measure is that your learning is to able to solve past year problems, because I know students who are not being able to solve past year problems even though they know the theories. So that means they're probably not progressing, okay? Or something is missing, some missing link is there. So therefore, it's a feedback to our teachers also that what we are teaching in the class is actually coherent with what you're expected to do in the examinations. And I believe examination problems are really good estimators of actual knowledge, and you understood the real knowledge, okay? So the 2 parts, one is a past year problem set, and another is individual problems that we select from special books and special sources. Sometimes we make the problems ourselves. So the problem solving classes will be taking a subset of these problems and solving this in the class, okay? That's the whole idea. And we have implemented different sets of problems, but I think this strategy has worked really the best, and this will be working. So we will try to give our assignments few days before the problem solving session, so that you can get a time to look through the problem solving sessions, okay? Sometimes faculties need to give the problems after the problem solving sessions, so accordingly they adjust it. And the final aspect is that it's special classes. The special classes are taken by faculties. I will take a few of them. Other faculties, we call people from all of this. Is something we'll be introducing this year, and it's going to be fun and it's interesting. It makes the classes very fun and enjoyable, that you learn the connections. So we'll be calling people out there, students out there, to tell you connections between different topics, different ideas, different things. For example, we have understood about, if you have seen the practical BSc thesis, bachelor's thesis and project that Anik has done from St. Xavier's College. I don't know if you have seen that video. So we will be calling people out there to have the special sessions. It will not be live, but it will be recorded sessions mostly. Some of them will be live, which I will be doing personally, but some of them will be recorded. So these special sessions are meant to weave and see you through the knowledge and make a beautiful structure of it. For example, we will learn how Markov chains are built. Markov chains are nothing but taking linear algebra and probability and clubbing them together and giving something beautiful. We can estimate that the number of, so for example, using Markov chain, using linear algebra and probability, we can estimate the expected number of games to for a snake and ladder game in Bengal. It's called, I forgot the name. So what is called its Bengali? Sharp and
Sharp Shiri.
yeah, sharp shiri. So yes, so snake and ladders game is very important. uh an important part of people, I used to play that with my grandmother, so it's a very important part of my life. So understanding how probability and linear algebra learning is connected to that, it's very interesting. Also, there are problems like, I remember in your school days, I don't know, I mean also in your college days, We used to get chips packet or something. Like for example, there was Kinder Joy, and we used to get gifts from there, right? And also Google Pay does this. So uh, you know that each packet contains, let's say, 5 or different type of gifts. So what is the minimum number of what is the average number of um, chips you need to buy so that you get all the contents back, all such gifts? Okay, so similar such problems, such fun problems that make your uh, that makes you fall in love with the subject. Okay, because we love the subject who we are teaching, so therefore we want to share that aspect of it. We have kept one special sessions, we can keep it more, but we have kept a part of it because I'm sure you will love it. Okay, so coming to assignments, because there's a way to understand, as I have told you, that there are two types. One is solving, one is reading. The solving assignments are, you have to solve it, just solve it, okay? And you have to submit the solutions. We will grade it and we will check your solutions, because understanding writing mathematics is a very important portion of your because that will set you apart from other people, okay? And we have seen, like we have done this. So you may think that, oh, I will only write mathematics, how will I prepare for MCQs? I can give you written proof, I can give you live proof of people who are getting 60%, which is a very good, or 55%, which is a very good score in mock tests, by doing this and focusing on the MCQ by focusing on the mock test. Okay, so whatever we are doing, it works and it helps you build your foundations. So we are talking about like this current life students who will giving their exam this year. I hope they will do good and set an example for you as Cheenta graduates. So solving assignments, you have to do it, write it down, and I will check how you're writing mathematics. I will check personally, because I think that I should do that so that I can understand where you're progressing and correspondingly, operate and introduce pieces so that your learning curve is smooth. So you have to solve it and write the assignments down, and I will grade it personally. Um, that's number one. And reading assignments are, as you know, reading assignments are something like some books references we will be giving, and some uh, extra reading material, some PDF online we will be giving, because a lot of information is available and very beautifully. So for example, we have notes. Personally, we will give you notes to understand and understand the connections and everything, and summary and stuff like that. So this will really help you in the studying outside the the coursework. As you understand the course, the classes will help you in giving. So why the classes will be helpful to you? Because while you're studying, you don't get the intuition, don't get the fun of it when you are learning from a book usually. So our job is to give you the direction and make a path, okay, for you, so that you learn in that way. And it does not, so when you're going for traveling, you not only travel, right, but also you stay for some time for some places and enjoy the thing. So that's the part of the reading assignment, that you stay at some point, read the books, and you ask questions and doubts, and ask the doubts at the end of the class or in the groups, okay, that you've been doing for the past few weeks for the mathematics part. And that's the whole idea, okay? That's the whole idea. And you must do all of this, both of this, to make your learning very, 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 very smooth. And there's only one requirement: just do this every week, okay? That's it. You have a reading assignment, you have a classes, you have assignments, and you have reading assignments, solving assignments, reading assignments. So classes will take around 3 to 4 classes, 5 hours. 1.5 hours into 3 is around 4.5, plus 30 minutes error I have kept, 5 hours, plus 4 hours assignment solving, because you have to solve at least 10 problems each week. So at most you can need is 4 hours, but you should solve. We will give more problems, like 30 problems, 20 problems, more, sometimes 50 problems, okay? So that you can at the end, like at the end of the course, when some week you will be doing all the problems before you can do the past problems, okay? And it is 6 hours for reading assignments and reading for books, and 15 hours every week. I think it's doable for every single student who are starting out early. So it's around 2 to 2.5 hours every day, okay? Or you can do everything together at the end of the week. That's how we have done this course, and it has worked for the students have seemed to benefit from it. So as you can see, classes will give you a direction to learn, assignments will give you apply the knowledge, the concepts after the problem solving. Classes also, the reading assignment will help you go in deep into proofs and build your foundations well. So now the coming to the books aspect of it, for the books part, understanding real analysis has been the most important book for my learning purposes, because I have learned in my entire real analysis and calculus from it. Okay, it's beautiful. It will tell you all the beautiful concepts and connections and everything, and you will love it absolutely. uh, it starts with the story of how, so it's a perfect blend of story and mathematics, perfect mathematics. So it starts with the story of how, there's a straight line. So initially, now understand, let's understand this. So initially there were integers. Okay, they're like positive integers. How did the positive integers come? So someday one Neanderthal man or woman, they were went for hunting, and then they saw that they have this fingers, 5 fingers. The five was not there in the concept, and they have 5 maple leaves. So they saw connection, and they started to connect this two, and they saw, okay, let's this be one, let this be two, let's be three, 4, 5, and this way they have counted 10 fingers. And that's why the decimal system, the entire decimal system of numbers are based on this 10 fingers. Okay, because so that they count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11 comes here. It's a decimal system. Okay, it's modulo 10. So that's why the decimal system was built in the early days based on the fingers of human beings. So if it was hence, if it was spiders, then they would have done a modulo 8 systems. It's a mathematical joke. So so initially they were integers, positive integers, and then they asked the simple. So then mathematicians started to do algebra, and they asked a simple question that, is there a number which when added to 1 gives 1? And that's where they discovered 0. And once they discovered 0, they asked a simple question that, is there a number which when added to itself gives 0? And that's where is there a number x which is when added to a number a gives 0? That's where they discovered negative of integers. Okay, and once they are done, the whole integer set was done. And then they asked the question that, if you observe that if you multiply or divide these two numbers, so understand these integers, if you add or subtract two integers, they're within integers. But if you divide two integers or multiply even with two integers, they're integers. But if I divide two integers, they are not integer. So they thought, is there any such x such that when it's multiplied with every such integer or divided by any such integer gives similar things like x? Okay, that's where they discovered rational numbers. Okay, and this time it's very important. Rational numbers are beautiful. The next step was that they got Pythagoras. Then the Pythagoras came. That he discovered Pythagoras theorem, and then they saw that the hypotenuse length was √2, which is not a rational number. You know this proof, right? √2 is equal to p by q, and they proved that it was not a rational number, right? So then they discovered that there is some other number that is more than rational number, √2. So then they discovered irrational number, and they found out gradually by this that if you put out and draw the rational numbers on the real number line, the irrational numbers exactly puts in the blockage and the holes that were there. So this, and using this irrational numbers and rational numbers, the entire line is continuous. So this is called axiom of completeness. Okay. Also, if every number, if you take a rational number and a rational number and a rational number, why rational number was working really fine? Because every number you can approximate a rational number, sequence of rational numbers. So if you remember, let's take any irrational number. Irrational number has an infinite decimal expansion, right? So let's say √2. √2 is 1.414 x, y, z, blah blah blah. So if you take 1 as the first rational number, 1.4 is second rational number, 1.41 is third rational number, 1.414 is the fourth rational number. Similarly, you can do, and you can get an infinite sequence which converges to an irrational number, right? So since people were approximating at that time, they didn't know that there are irrational numbers existing. So this is the axiom of completeness. You can take rational numbers and you can get a limit which is maybe a rational number, which may be an irrational number. But if we put that limit into this set, that will become a totally complete set without holes. And this is called the axiom of completeness. I told it in a very simplistic format, but this is the whole story behind it. So how the real numbers were developed. And from there, you can understand that to develop the real numbers, we need sequences. So that's why the first thing is we are learning real analysis, we need sequences, okay? Because using sequences, we can put in the holes, we can make it complete. So therefore, we'll first learn sequence, and then as a natural extension, we'll learn series. But sequence and series already existed before during Archimedes, because we use sequence and series to estimate the volume and to estimate the area under the parabola, okay? Maybe we can do that problem. So That's the fun part of it. So when you learn this story, you get, you are feeling and you are reading back and you're seeing the whole story of mathematics evolving in front of you. You feel that the whole mathematics is, you feel it, a human attachment to it. Okay, you feel that it's not dry again. It's very beautiful. I don't know how many of you like to read storybooks, but our personal goal is that when you're first learning, you should be learning this kind of books which can give you a story, which can give you a push towards understanding what's the intuition, what's that X factor in learning these things. And this book has tremendously helped me to learn that in the first attempt of learning things, these are the kind of books you should learn, not the Tars books that are written without diagrams. Those are important for revision purpose because those are short, those are crisp, and those are important for the second time reading. Okay, people mistaken that, you know we love to read, we love stories, human beings love stories. So this kind of books I have kept it here, but also your other books, if you like that, of course you must go to a this is how I discovered this book. Okay, in ISI I went to the library there. It's a beautiful library, you should visit it someday. So in ISI Kolkata, and there was a whole analysis calculus section. I went there, I spent one day, I read through every book, first through few pages, and after reading this 3 few pages, I loved this book. Okay, I took it and I learned the entire analysis from here. I did almost many of the problems. Okay, we will give some problems from here too. One problem is that, let's say, convergence, right? So there's a definition of convergence, epsilon delta. Here in this book, there's an interesting question that what if we replace delta by epsilon and epsilon by delta? Okay, what if we change the definition? Will it still be convergent? So it's fun. You will love solving this problem. It's like a puzzle. Okay, so this is one such book for the real analysis. It's univariate calculus and linear algebra. Gilbert Strang has been my only. So linear algebra is born out of geometry, right? From the planes, from the lines, from 3D. Okay, so linear algebra is nothing but approximating the entire world by lines and planes and understanding the geometry. That's why it's called linear spaces, linear algebra, because it's linear. We are taking linear spaces and understanding them. So these are the inherent geometry in it, a basic intuitive structure in it. Okay, so the goal of mine and Cheenta's is that to show you this inherent geometry, to show you the beauty under this carpet, what's lying under the carpet. Okay, and this is not there in every book. So therefore we have selected these few books. Gilbert Strang lecture is also online. You should watch that. So column space, null space, and everything is a specific geometry. And once you understand the geometry, every problem becomes like geometrical. For example, the row space and the null space are perpendicular to each other. Okay, that's why there's a specific solution. First, you find a solution, and then you add all the elements in the row space to get all the solutions. So these are very beautiful. Okay, and I cannot tell you how I have no words to express it. Okay, so it's beautiful. You should learn that, and you should learn these books, and it's like for your juniors, for your future, you can tell these stories to your other people. You can tell stories to people who don't love math. You can make them fall in love with math. Okay, and then multiverse calculus. This is not beautiful. I mean, this is a beautiful topic, but we don't have the extensive. We will try to give our best to make it so beautiful, and it's elegant when you see the structures. But essentially, it's an extension of the univariate calculus. Okay, so once you go to multivariate calculus, you don't need so much of geometrical ideas to it. One thing that I will make a special lecture is Jacobian. Jacobian is a very, very important concept, and it's nothing but approximating every curved surface. Let's say it's the curved surface, approximating this with a plane. And for that, you will see how multivariate calculus takes in linear algebra and analysis and clubs it together. Okay, so multivariate calculus, we've kept it last because it combines both linear algebra and real analysis. It's in 2 dimensions. So everything of mathematics and everything of probability and everything of statistics are connected to each other. Okay. So, for example, you can see, I don't know if you know testing of hypothesis, but there's a geometrical. We will not teach you this, but there's a paper in that the UMP test, the best test in testing a hypothesis, is a tangent to a curved surface in certain dimensions. Okay, so it's the best test approximated to a certain test. All the set of all tests. So that's why UMP tests are really good. So you can prove this mathematically, but for that you need to have the technological arsenal in your list, in your mind, to help you understand these beautiful concepts. So therefore, mathematics is a very basic, bowl of knowledge you need to have, and then comes probability. So yeah, I think after this, so yeah, this is loving and the beautiful part of learning, and then comes a big reminder that you have to make your own cheat sheet. So whatever books you're reading, whatever reading materials you're reading, we are giving, whatever Cheenta notes you're doing, and the assignment mock test, this will help you make your own cheat sheet. Don't forget to make your own cheat sheet. It's very important. I mean, it's a reminder to you. And then remember that group studying is very important. I don't know if you have formed grouped or not. Do you want me to make your groups, guys, or do you want to work alone? So let me know after this. And yeah, so that's it. And I think this is a very, very important way we have found out that helps students to learn and prepare at the same time. And we have personally enjoyed as teachers to teach this way. So that's the whole aspect about mathematics full course. Similarly, I will do it with every full course before starting to help you give an idea. So any questions for now on, guys, for the course, for understanding about how we will work? The classes as of now, I think it's on Monday. One of them I forgot the dates. It's from 7 to 8:30 p.m. It's on Monday. I will check the WhatsApp group. I think it's Monday, Wednesday, and Friday from 7 to 8:30 p.m. Okay. So any questions from you guys? No? Okay, that's great. So you will have 1 week to solve your assignments and submit it. For submission, yeah, I will come to that. For submission, you will have 1 week to submit, and after that it will be graded. After 1 week, it will not be graded. It's just to make you very disciplined, because without discipline, I don't expect good results from you. You can learn, but for you have to also prepare for the examination and have a good habit of problem solving. All the toppers, all the people who have got into the exam, they have good habits of problem solving every single week. So understand, there's one simple catch, and if you get that catch, it's it's very easy. It's this catch. Just do this every week, 15 hours every week. Even if you can't attend the classes and do the assignments, reading assignments, you can delay it, but doing the classes and assignments is 9 hours. Okay, that's 1 to 1.5 hours every week. Okay, so even if you have exams, if you just are a bit disciplined, every single morning you wake up in the morning and you do the assignments, and you have the classes specific timing. If you miss the classes, the recording. So see that, make a specific thing and do that. Simple stuff. If you can do this, it will be really, it will be really awesome. Okay, and it's a habit. Once you build that habit, no one can stop you from, moving that habit, moving from that habit. So whatever work you have, unless you're sick, you should do this. That's the kind of mentality you should have to learn as well as succeed in the examinations. If you want to learn and not succeed, it's fine. You can do whatever way you learn, whatever way you want to learn, whatever way you want to study. It's your choice. But for succeeding examination, this is a plan and discipline we have made for you. And instead of you thinking about it, so we expect you to follow, and the grading will tell you what is happening behind the screen, behind your mind, where to improve. Okay, coming to questions. Sai has a question that would you explain also how much discusses. Okay, so I will give you examples in the examines. You mean the assignments, Sai? You mean the assignments? Okay, yeah, so I will give you examples. That's not a problem at all. I think the way people are writing, that's why I asked you to write down the solutions in mathematics. The way we are writing down and explaining things, that should be enough. Okay, that should be enough. So essentially, the idea is that the main thing I am looking into your work is that, for example, people do this. Okay, I will tell you basic things. Let's say there is a question. I give an IIT exam question. There are options. So for each proving the problem, you have to disprove or prove each of the options. Okay, so what they do for proving, they take examples and they see, okay, there's a pattern, and they prove it. This is not the way to write mathematics. Okay, mathematics is like poetry. This is something I should tell you again and again. So mathematics writing is similar to writing poetry. All of you can go beside the river and go and sit under the front of a tree in spring, and you can sing a song I mean, or you can feel the entire moments and you will feel totally beautiful and everything will seem so flowery. But only poets can write and express and express that feelings into words. Similarly, mathematics you can feel by exams. Oh, this is happening, this is happening. I'm finding this pattern. But to express it mathematically, you need language. This is the relationship with poetry and mathematics. Okay, it needs a language. You have to learn that language. Without that, you will not. You will experience it, but you will not express. You will feel that there is a gap. Okay, so this is what you should focus on, guys, during this 1 year, and this is what we essentially ask you to write descriptive answers and we grade it. So these are the things we make sure that it's in the whole writing procedure. It's not like you have to write an essay out of it. It should be understandable. Okay, the steps and the idea should be understandable. Write it as if you're giving the ISI MStat examination. Okay, and I can tell you these are the ways you can take a change and you can go around, and then you will improve yourself every single iteration of assignments. Does it make sense? Great. Any other questions from you guys? Any other questions regarding the course? You can raise your hand and unmute yourself instead of writing. Okay. Okay, that's great. So our classes will start from the first week of February. Okay, the first week of February, or 1 week of chilling left. So chill as much as you can. Then life will not be chill at all if you want to succeed well. The choice is yours. So I will see you. We will see you soon in the classes. I'm so excited to share our knowledge with you. Before that, I will sharing some introductory videos to you so that you can learn and start learning about basic mathematics, basic real analysis. Download the books down and start reading them. I've given the books. I will hope that you enjoy the course with us. I hope we enjoy teaching you. And it's a two-way thing. Students have to submit assignments. I will tell you one single number. We have 70+ students in our past course, and only around 9 to 10 people at most. So 10% to 15% of people submit the assignments, and I'm sure no one outside that range will ever get in. They are learning. They have told me they are learned, but they will not get into IIT or ISI because it needs a certain kind of demeanor and attitude towards problem solving. So the question is that there are two aspects to it. Whether you want to be in that 10% or 50%, everyone wants to be. The second part is that will you be able to do it? Yes, we will be able to do it for 1 or 2 weeks. The third question is that will you be able to do it consistently, even when you're, when you're not feeling like doing it, even when Tesla stocks falls down, even when Arijit Singh attends your feast or not, even when whatever happens in your life, are you being able to do that or not? That's the kind of attitude you need and discipline you need to succeed. And that's only few people can do it because it's hard. So the question is whether you will be able to do it or not, whether you will be able to focus it or not, whether are you planning to do it or not. The choice is yours. But at the end of the day, at the end of the 1 year course, you will learn a lot because most of the people attend the classes, okay, and watch the recordings. So that I can guarantee you. And then the aspect of doing problems and solving, it's for your benefits, for your choice, left to your choice. So thank you guys, and I will see you in the classes soon. I'm so excited to have you in the classes. Stay tuned and stay blessed. Bye bye. Have a great day ahead. Great night ahead. Bye bye.